To finish off Chapter 6, we're going to look at our final lesson called More Measures of Spread. I'd like to backtrack just for a moment. We looked at central tendencies before we looked at measures of spread. Two of our central tendencies we looked at were median and mean. I'm going to do mean first and median second. Central tendencies with respect to a data set. And when we feel it's more appropriate to talk about the mean with respect to a data set, we can talk about the measure of spread with that data using something called standard deviation. And this was talked about in lesson 2.5. When the median is a better measure of the central tendency for a group of data, the measure of spread we should use instead can be broken down into a number of different things. The first thing we're going to look at is something called quartiles, but we can also talk about things such as percentiles and we can also look at something called z-scores. And these will be the focus of this final lesson. We will learn about quartiles here in 2.6b. Sorry, this was 2.6a, my bad. And we'll also learn about these ones here as well, but it's going to take a couple of videos. I'll do sort of one for each one because the videos will be too long otherwise. So let's get started. I'm going to let you read through your note on quartiles. You have the handout already, but what I'm going to do is go straight into the examples, and then what you're reading about will make a lot more sense. So let's begin with looking at a set of data points where there are an odd number of points in total. And we'll also do an example where it's even later on. In example 1, it asks us to find the median, Q1, Q3, the interquartile range, the semi-interquartile range for this set of data points, and then to create a box diagram from it as well, or sometimes called a box and whisker plot. It's the same thing. You'll notice that the data points that are given in our example are not in order, and we need to do that in order to determine the median a little more easily. So let's begin by doing that first. Our first data point is 24, followed by 43, 52, 61, 67, 72, 78, 83, 87, 91, and 94. So, to find the middle or the median, you'll remember that we can leapfrog from both ends at a constant rate to see which point ends up being in the middle. And when we do that leapfrogging process, we notice that 72 is in the center. So we're going to label this as the median, but when we're breaking this data set into 4 equal groups, we can call this Q2 or quartile 2. Okay. So let's now look at the remaining halves and see if we can break them into equal groups as well. Well, because there are 5 points here, if we allow 52 to be Q1, then we've got 2 data points, 2 data points, and they're evenly distributed amongst these sections. We'd like to do the same thing on the other side as well. So the middle of these 5 points would be quartile 3. Okay, and again, there would be 2 points on either side. So now this is symmetrically divided into 4 sections. What we're going to do now is translate this into, as I said, a box and whisker plot. So I'm going to draw the boxes that you have there. And normally these would be very faded so that the box and whisker plot can stand out. I'm going to have to use black in this case to allow it to show. And I'm going to take, and you can label your lines in as well. I'm going to allow every line to be represented by 5 so we can get a good spread for this data. 24 will be in there and 94 will be included as well if I go all the way up to 100. Sorry, I was writing 50 while I said that. There we go. 100. Okay. And yours looks a lot neater than mine, but you get the idea. All right, let's go ahead and let's plot these then to create what's called a set of box and whisker plot. Let's begin with the median at 72. So again, 72 is going to be not quite halfway between 70 and 75. And if I want to be explicit to the reader of what that value is, I could put it up above if I wanted to. I'm going to do the same thing for the other 2 points for Q3 and Q1. 87 will be a little bit past 85. And Q1 will be a little bit past 50, but not quite 55 either. And then I can create the box. So the box surrounds Q1 and Q3 and keeps the vertical line in the center for Q2. You can color it in, not color it in. I'll just shade it just to let it stand out a little bit more. And I've left the colors in so you can see the association with where the edges of the box came from with respect to your data set. Now, in a box and whisker plot, we also want to show the lower range and the higher range, but with box and whisker plots, we can also use a quantitative tool to see if in fact 24 and 94, being at the extremes of the data set, are outliers. So we haven't been able to do this yet in our study of statistics. So in order to see if they're outliers, we're going to do a couple of quick little calculations. The interquartile range is defined as the difference between Q3 and Q1. So if I plug in 87 minus 52, I can see that my interquartile range is 35. Now the semi-interquartile range, which I'm going to call SIQR, is simply the IQR divided by 2, or dividing in half. So 35 divided by 2 means the semi-quartile range would be 17.5. All right, here's our outlier test. Let's take a look to see what the lower outlier range should be for this data set. To do that, what we do is we take Q1 here, and we're going to subtract 1.5 times the value of the interquartile range. So plugging in some numbers, we get 52 minus 1.5 times 35. Or you could substitute all of this with 1.5, or adding these two things together in this section as well. And when you do this calculation, you find that the lower outlier range should be negative 0.5. So that's, out here. Okay. Fortunately, 21 is well within the range between that lower outlier value and Q1, so 24 is good. It's not going to be considered an outlier with this data set. We're going to do a similar calculation for an upper outlier as well. In that this time we can take Q3 at the other end of the box, and we can add 1.5 times the value of the interquartile range to see if 94 fits. So Q3's value is 87, and we can multiply that by 1.5 times 35, or as I said, you could substitute all of this with 35 plus 17.5. And we discovered that the upper limit for this data set should be 139.5. And again, that would be way out here somewhere. 94 is well within that range, so it is not considered to be an outlier either. So we can say, therefore, there are no outliers in this set. To show then where the lower range and the upper range are for this data set, we can take 24 and plot it here as a dot for the lower range, and do a similar thing for 94 for the upper range, and then we can connect that dot to the edges of the box part, thereby creating the whiskers, if you will. And if you wanted to be explicit and say this value is 94 and this one is 24, that's okay too. If you've got a really good scale box to work with, those numbers would be apparent. You could read them right off the graph. Okay, let's take a look at another example whereby this time, instead of having an odd number of data points, we're going to have an even number. And what I'm going to do is I'm going to take the same set of data, but I'm going to instead add 158 to it.